Hi everyone, welcome to this demo. So before jumping into this demo, I just really thank you for all the love and support and the personal messages which I have got during this week for this AWS Orchestrator Agent. So keep supporting this project and let's make it a successful. Okay. So today I'm going to demo this Planner Agent, which is part of this multi-agent framework. And this Planner Agent is itself a subgraph, and it constitutes three sub-agents working together to analyze the user requirement. Okay. So for this demo, I have already ran this agent into debugger mode so that I can show you what are the data which I am collecting during individual steps of this planning phase. Okay. So the server has already started and client has already initiated. Okay. So from the client, let's send a request saying, can you help me in writing AWS S3 module? Okay. So the main supervisor agent has forwarded the request to this planner agent, and the planner agent has initiated or forwarded that request to the requirement analyzer React agent. Okay. And the very first tool which it ran is this infra requirement parser tool, which is nothing but ask the user requirement or convert the user requirement into specific AWS services. So if you look at parse response rate, so it says the scope or the classification is single service, and the service which user has asked for is S3. Okay. So yeah, this is how this tool converts the user requirement into AWS specific service. So now I will pause this and I will see you on the next run. Okay. So from infra parser tool, the request goes to this AWS service discovery tool, which maps the AWS services to the corresponding Terraform resources. So the identified Terraform resources for AWS S3 is these resources. Okay, S3 bucket policy access, encryption configuration, versioning, lifecycle configuration, and bucket S3 bucket policy. And it has also identified what are the various cost optimization recommendation and the architecture pattern as well, and also it has identified the dependencies which it needs to create this many resources. This is the exact role of this AWS service. So the final tool which ran in this requirement analyzer agent is this resource attribute tool, which is nothing but maps the required attributes corresponding to that at AWS resources. So if you look at the output, so this AWS identified resource name was AWS S3 bucket. So now in the module design, it has recommended that these many will be the attributes. So attributes like bucket prefix, bucket ACL, force destroy versioning, server side encryption, connection logging, lifecycle rule. So they'll be these are the attributes which will be part of this resource, and this will be the recommended outputs: ID, ARN, domain name. So, so it has collected all the data. Now it will forward the data to the executional planner, which plans the overall module. Okay. So I will again pause it here, and I will show you the individual tool results of the executional planner agent. Okay. So now the execution planner agent has started. So the very first tool within this execution planner agent has the execution planner agent has run is this model structure plan tool. Okay, which creates the corresponding service module structure. So if you look at this output, so it has recommended files like main.tf variable output version depending upon the identified resources and the attributes. Okay, and it has also created output definitions, and the output definition is bucket id, ARN, everything. So if you look at individual one, so it has given the description and the justification why it recommends this bucket id to be the output of this module. Okay, same goes for variables and the reusability guidance as well, and it has also given recommendation regarding the security consideration. So from this tool, this the request will goes to tool within this agent, which is nothing but the configuration optimization tool. So yeah, I will again pause it here, and I will show you the response of that configuration optimization tool. So this configuration optimization tool optimizes all the configuration which has been collected by the previous tool run. If you look at the output, it has identified the cost optimization for this resource AWS S3 bucket. Okay, and if you look at the output, it says the current configuration is standard storage class with no lifecycle policies. And it is also saying justification, right? Transitioning infrequent access data to lower cost storage class. Okay, and for cost, it has also collected the data regarding this implementation priority. Okay, and it has also collected data regarding the tagging strategies. What will be the tagging strategies which will be incorporated in this module? So if you look at the overall tagging strategy, the required tags is name, environment, application, cost, state, center, data classification managed by and Terraform module. So it has identified the right set of tags which will be there for every resources in this module. So yeah, this is the role of this configuration optimization tool. So I will again pause it here and I will show you the result of the next tool run within this execution planner agent. So till now we have this module structure plan and the configuration optimization plan, right? So the third item was missing is this backend configuration. How will be the state looks like? So for this state management tool, it plans what will be the backend configuration as per the user ask service. So for S3, it has recommended that the bucket name should start with org, Terraform, state, S3, and the region. Key patterns with this will be encrypted via customer managed key, and it has also given a set of best practices to be followed for manage this backend configuration or the state file. So it's split state by environment, use a CMK, prefer pay request for low concurrency. So this tool has given all the required information which needs to be incorporated while writing the exact backend.tf file, right? So the final tool run within this execution planner is this execution plan tool. Which is nothing but it consolidate every tool runs into a single JSON object. Okay. So if you look at the output, so it has identified the data sources which needs to be there at module side is a current caller identity, current region, remote state platform shared, and remote random ID suffix. Okay, and IAM policy or the bucket policy will be this AWS S3 bucket access policy. Local values, it has identified, so there should be a local value name as final bucket name, merge tags, public access settings, everything, and you can find all the details. It depends upon this bucket, this variable var.bucket name, var.prefix, var.application, var.region. Okay, so this is local value entry. Output definition, it has identified that these are the outputs: bucket ID, ARN, domain name, region, domain name, hosted zone, bucket site, endpoint versioning, state. It will be part of a module. Okay, and there is this readme content which will be part of this documentation, and this is the required provider which will be part of this backend.tf file, and the resources, the actual resources which this module will provision is AWS S3 bucket policy, bucket public access, server side encryption, versioning, lifecycle, and policy, right? And if you look at individual details, so here the bucket name is coming from local value, ACL is coming from where, post destroy again it is coming from variable, versioning, server side, logging, lifecycle rule, everything, right? So all these details it has consolidated, and eventually this output will be given to this dependent agent, that is form generator agent. Okay, so eventually this output or whatever the result it is showing, it the required models will be written in the generator's form. So yeah, so this is how this or I am doing this planning phase. So what I will do, I will upload all this planning results so that you can also evaluate at your end. Okay, and yeah, so if you want to contribute in this project, so I have already created Discord server. I will pin that Discord server in the comment. Also, I have uploaded this Docker image, so in case you want to run locally, just pull that image. And so I will stop it here and see you on the next agent video. Okay, yeah, thank you.